In this tutorial, we're going to showcase the Denario app, the graphical user interface where we will run the multi-agent system of Denario to assist us in our research process. So for this example, we're going to make use of this publicly available data, the Hipparcos Stellar Astronomy Catalogue, which is essentially a table which identifies data of many different stars, including different astronomical quantities such as the right ascension, declination, visual magnitudes, stellar type, etc. First, let's download it. Then add it to our folder and open the terminal. Here we have a virtual environment with Denario installed. To launch the application, we can run Denario run. This will open the application. Here you can see the graphical user interface where we will be running Denario. In the sidebar, we have several options. First of all, we have a place where we can put our API keys for the different LLMs that are supported in Denario, such as Gemini, OpenAI, Anthropic, and Perplexity. We can set them up here, or we can put them in our .env file. Just drag and drop it here. However, if running this application locally, we can have all these API keys in the .bashrc file, and the Denario application will access them directly, so there is no need to place the API keys manually. Here we have the place where we can drag and drop the data. So now the data has been loaded into the application folder. Here we have a folder that has been created directly when the application was launched, which now includes the Hipparcos data. Here we have the different modules which are included in Denario for the different parts in the research assistance process. First of all, we need to describe the data and the tools that we want to use in our project. So since we are going to use the Hipparcos Stellar Catalogue, we need to give a brief description of that. We are providing a very generic prompt to analyze the Hipparcos Stellar Catalogue included in the data folder. And then we are going to add some other requirements for the tools that have to be used. For instance, you can make use of libraries such as SciPy, Pandas, or NumPy for analyzing this data. And we can also add additional requests. To ensure that we are producing visualizations of the data, we can add a line for that. Make plots for comparing and showing the results. We can now save the data description. And then we can start generating a research idea. Given the data description, we can query Denario to provide some ideas to start our research process. So for that, we have two different options. On the one hand, we have the more computation expensive option involving planning and control agents through the CMB agent backend. But for this task, which is looking for an idea, we can use the other option, which is the fast generation using the LangGraph backend. We will go with that for this example. Here we can also choose the different LLM. But since this is a simpler task than the other modules, we can go with the Flash Gemini model. So let's generate the idea. So in this case, we have interplay between two agents, the maker, which is making a proposal, and the hater, which is critiquing and providing feedback. Together they are, step by step, refining the proposed idea. Here we have the proposal. Investigate the relationship between the stellar colour and the distribution of proper motion anomalies in the Hipparcos catalogue, and it goes on to give a more in-depth description of that. If we are okay with this idea, we can proceed, and if not, we can generate another one. For this example, we will proceed with the given idea. In this module, we are generating the research methodology that we need to follow in order to compute some results step by step. So basically, the operations that the agents need to fulfill in order to carry out the research process. So for this we can, again, choose between the CMB agent backend or the fast generation. Let's continue with the fast one for now, but you can experiment with different options and also try with different LLMs. So here in the log, we can see the planning that the agents are proposing. And below we have a detailed plan for the research. Starting by loading and pre-processing the data. Next, perform exploratory data analysis, providing some summary statistics and filtering some errors. So this looks good to me. Let's proceed with the research plan. Note that all of these modules are in some way independent, so instead of generating these methods, we can drag and drop a file here with a manually defined methodology within, and the same for the idea. In this module, we will carry out the proposed research plan, following all the steps, download the required packages, write the code, perform the calculations, output the plots, and summarize the results. Here we can set the different LLMs to run for the engineer and researcher agents. For this example, we are selecting the Claude models, but we can use whatever we want, so feel free to experiment with these options. Here we have some other advanced options. For instance, we can choose the maximum number of attempts for the code execution, since the agents could fail sometimes when downloading some library or running some code. There are 6 attempts as a default, but we can modify that. Also, there is an option to restart a given number of these steps, or provide some hardware constraints, such as using a GPU or indicating the number of CPUs available. We can also choose the planner and the reviewer models, which will also be used in this module. So let's stick with the default options and start generating. We can see that the agents from the planning controller are starting to work, establishing the tasks that they need to fulfill. This may take a while, since this is the most computation expensive part. So here we have some code that the agents have written and run. And now that it's finished, we can also see the different plots that have been created by the agents, as well as a summary of the results of our research. Also, if we return to our folder, we can see all of the outputs. For instance, the codes that have been written by the agents. And here we also have the summary for the results and the methodology, and the generated plots too, so you can visualize them here. Now that we have the analysis with some plots and some conclusions, we can go to the paper module. Here we can write a scientific article presenting the research and discussing the results. For instance, we can choose the Gemini Flash model for this example and choose the style for the journal. We have several options. In this example, we will choose the APS or Physical Review journal style. And we can also describe the type of researcher that we have. For instance, if we were looking for biology research, we would specify that this would be a biologist. For now, we will continue with the default scientist researcher. Let's generate the article. This will also take a while. After around 10 minutes, the article module has finished, and here we have the paper it has produced. It has created a LaTeX file and compiled it to create a PDF. You can see that we have the title and the abstract as expected in a research paper. We also have the relevant equations, the proposed methodology, many other sections including the plots that the results module has created, and finally, the conclusions. Also notice that we can see here the style of the APS journals, the one used in physical review papers. Lastly, the bibliography referenced in the citations. It's possible that this article might not be high-quality research. In order to achieve this, we need to provide a great amount of human feedback to the loop, in the generation of the idea, in the methodology, as well as in the results and paper modules. Any of these modules can be run independently and can help us in each of the steps of the research process. Before finishing, let's briefly mention that we have two other minor modules here. This one is to check that the proposed idea has not already been developed in the literature, in order to assess the novelty of the idea and ensure that it is original. And the other module is for generating the keywords from the input description. As before, we can go to the paper section here and see all the different versions of the paper. The preliminary version, the version without citations, the version with citations, and the final version after some refinements. We can also directly access the text file and modify it as we want. We can click here to download all the project files if we wish. I hope that this video has helped you to understand the Denario application and learn how to run Denario using the graphical user interface. As mentioned before, feel free to experiment with different LLMs and different options, and we hope that it can be useful for future research. Thank you.